Welcome back to our afternoon session in the water stream. So this afternoon, we have a presentation from Bart Nielsen. Bart's a senior control systems specialist and team lead in MPE engineering in Nanaimo's office. He values the early days in his career when he started out as an operator, as that background has provided him experience like no other when building control systems. These days, Bart coordinates projects, helps municipalities bridge the gap between operational technology and information technology, writes proposals, teaches courses, and still does a little bit of programming. So with that, I'm going to turn it over to Bart, and he has a presentation for us.
Thank you. Loud and clear? All good? Excellent. Thanks for attending, guys, and hope we're going to keep you awake after this lunch at 1 o'clock. The first one that starts nodding off.
Do I win?
This one. We're going to talk a little bit about control systems. Now, there's various vintages and types of control systems out there. Some of the stuff that we're going to be talking about today is intended to complement, potentially, your control system that you have that may be running your facility and helping you operate. Some of these things that we call current technology can be implemented with vintage type control systems. So we're going to be racing through a whole lot of different current technologies in general that may or may not all be applicable to your situation. And it's going to be relatively fast-paced. We got about 10 different things that we were going to jump into a little bit each over the next hour and a half, but I figured you guys in general are a knowledgeable and experienced audience, except for these three guys here in the front. Yes, I was going to pick on you. So let's get started. This is the agenda. We're going to be talking about these different subjects. I typically start out with my hero, Homer, operating the control panel. We're going to do a real quick overview of SCADA or Control System 101, the different levels and what makes up that control system, and then get into things like remote access. Cybersecurity, very briefly, we're going to talk a little bit more about that tomorrow at 1 o'clock. The Internet of Things that we've all heard of, but what does it really mean and how does it work for a control system? Integration with IT, we all to an extent have dealt with IT technology and IT resources. Some have better experiences with that than others. Talk a little bit about that. Control system architecture, and then emergency response. SCADA can play a control system can play a decent role in emergency response. Some alarm management, and then a little bit of the future of SCADA. So this picture is generating or is put together based on the 4 different levels that make up a SCADA system, a control system. SCADA stands for Supervisory, Control, and Data Acquisition. And these 4 levels, where we start at the bottom of this picture, where we are at the process level, where we have an analyzer or a valve or a pump, that's the foundation of your control system. That process level piece of equipment is controlled by a controller, an RTU, or a PLC that sits in a control panel somewhere, where inputs and outputs will be taken in from sensors, and the outputs will drive a valve to open or a pump to start. One level up from that is a communications layer. That's critical. I already see some yawning going on, so get ready. The communications layer is critical, and that's the part in a SCADA system that binds and communicates and brings all of that data together from all these different controllers and all these different sites even that could be distributed throughout your municipality. And then the top level on this is that supervisory level, where you as an operator will have a visual tool that allows you to see your pump being red when it's off, green when it's on, or the other way around, whatever your standards are, and you can control that pump to start and stop equipment, open and close valves. That is also often available remotely with that little box on the very top. if you have that type functionality. So these 4 layers or levels make up the foundation of a control system. And we're going to be talking a little bit more about that as we go through this presentation. The control system itself, I often say, it's like a pickup truck. And the reason I say that is because it's very complex. There's a whole bunch of different parts and components that all contribute to you guys using a control system as an operational tool. I mean, if your key in the morning doesn't turn your engine over and that engine doesn't say vroom, then your day is wrecked. And a control system is no different. If you are expecting to see your process through your control system and in some way, shape, or form doesn't show up the way you expected, your day is going to be quite different. So a couple of different items I've put on this slide, just like vehicles. There is a significant upfront cost, there's a lifespan, there's points of failure. It is truly part of your critical infrastructure. And I really want to stress that particular item is that if your control system is not available to you guys as operators, you will end up monitoring or controlling your process all of a sudden very differently. And therefore, I think it's very important that we distribute and we speak to leadership that it's critical infrastructure. Not everybody is on that same page. So, having said all that, the first technology feature that I wanted to address briefly was that remote access part. Operations can greatly benefit from having remote access to a control system to monitor and simply control the process remotely. So if you were to get a call out of some kind, without remote access, you may end up finding yourself driving to site, as opposed to taking a laptop or sometimes even a cellular phone and connecting to your control system remotely to see exactly what is going on with your process and what has generated that alarm. Remote access can just as well be used for support. We, as a service company, as a solutions provider, support dozens of control systems, SCADA systems, throughout Western Canada, and we do that mostly through remote support. Even if we have clients close by, remote support makes it easier and fast. And as far as remote access is concerned, engineering, operations, and management can greatly benefit from having access to the data that is generated by a control system. So the value of connecting a control system to the internet and providing that remote access at the end of the day is that you will end up reducing cost. And you can reduce that cost through some of these items that I've listed here. You reduce your travel time, you increase your speed for support, your access for support, using modern technology, increase productivity, and generating the proper reports for data, for compliancy, definitely adds value. And I've mentioned the alarm callouts, increases the response time. Now, with remote access, clearly we have this thing, cybersecurity. And cybersecurity obviously is a very hot potato, not only in our personal lives, but from a control systems perspective just as much, especially when we start talking about remote access and having a control system accessible on the internet. So I've put some statistics on here, just because it is such a big deal. We have over 50 new cyber threats reported every single day. 80% of vulnerabilities include outdated software. What is outdated software? An example could be an operating system from Microsoft that is no longer supported, such as Windows XP. And let's face it, there are water and wastewater operators that are using outdated operating systems, such as XP. And the risk with that is that Microsoft does not release patches anymore. They don't do updates anymore. And as a result, you're vulnerable and you're not being updated with the latest and greatest antivirus that comes or should come with your operating system. That's a huge risk. The third bullet on this one is interesting because water and wastewater, as it turns out, is one of the hardest hit sectors when it comes to cybersecurity threats, with an increase of over 122% year over year. If you look at the pie charts of the number of threats per industry, the one, unfortunately, for the municipal water and wastewater sector every year is growing and growing and growing very fast. Statistics have shown that over 50% of companies realize that there is a need to dedicate more resources to control system security, but unfortunately, the bullet after that says that only 15% of companies are actually doing something about it. And that's actually, these are 2019 statistics, so they're already a couple of years old. Unfortunately, those numbers have not gotten any better over time. And then the last one I found very interesting is to say that 99% of firewall breaches, and we'll talk about what a firewall is in a moment, are a result of misconfiguration. So what that means is it's human error. So cybersecurity is a big deal. What I wanted to really quickly present is that there are documents that can help provide a starting point for organizations, municipalities, and they provide a guide as to how one can start thinking about cybersecurity, what you can do. I've put these two organizations on there, the National Institute of Standards and Technology, NIST. They have some fancy document that is relatively lengthy, but it's actually relatively easy to follow. And then I've put Public Safety Canada on there, and the reason I put them in this order, even though we are in Canada, is because Public Safety Canada has endorsed this specific document from the National Institute of Standards and Technology, which, by the way, is a US organization. So the guidance that is provided in that document can be very helpful if somebody is looking to address cybersecurity. Some of these guidance or guides in that document are listed here. What do we typically recommend? Backup. Generate a backup. Make sure that you have a backup and follow a proper procedure for that. We often do the 3-2-1 thing where you have 3 backups. 2 are local, 1 is not local in case something really goes wrong with your, for example, water plant. If that happens to be on fire or get flooded, make sure you have an off-site type backup. User credentials. User credentials, by the way, that is the single most vulnerable or highest item on the vulnerability list. Having user accounts configured in your control system that are no longer active or are default. Default passwords of equipment, the third bullet on this item, refers to the fact that when you purchase a device and you install it in your facility, and that could be a network switch, that could be a router. If you think of a box that you'd purchased, you plug it in, that box will have a default password, login password combination in it. And that is available in the manual, that's available on the internet, and that's available to you or somebody who uses that box to configure that box for your specific application. So if you have admin as credentials for username and password, once you are done configuring that specific device for your application, you will want to change those credentials. 1, 2, 3, 4. Please don't use it. Exactly, right? Exactly. But some of the guides and the guidance documents when it comes to cybersecurity are not just talking about cybersecurity stuff. They are also talking about the fact that, hey, you can do everything right with firewalls and this and that and devices and lockdowns and credentials. But if you leave your front door open, you're just as vulnerable. So a lot of these things and a lot of these steps that we're talking about when it comes to security are common sense, and some are really almost too simple to think about, but they are really, really important. The next one is listed and it says eliminate backdoors. Now, what is a backdoor? A backdoor is a method of remotely connecting through a non-documented method. And there are a lot of control systems out there that have a backdoor that allows a programmer to provide remote support, for example. And what I'm saying is, don't allow it that way, because it's an easy way for a hacker to get into a control system. And make sure you use antivirus. Antivirus software, just like you should on your laptop at home or your computer at home, your computer in the office. Your SCADA system, your control system should have antivirus software on it as well. Make sure you install and test patches as they are being deployed and installed. Firewalls, I've mentioned this before, the word firewall. Basically, a firewall is a device that blocks traffic as per the configuration. Now, I put this whitelisting word behind it. So back in the day, when a firewall came out, we ended up configuring that firewall to block certain kinds of traffic. And that was called blacklisting. And we've now actually flipped that completely the other way around, where a firewall, if it's installed in your control system, should block all traffic, except for the little bit of traffic that is proven to be accurate and real. So for example, you with a laptop from your municipality or your company should be whitelisted to have access. But everything else that is trying to access your control system should be blocked. USB drives should never be used on a control system environment. They are the worst for transmitting and spreading viruses. And then monitor your network activity. Now that's a bit of an IT type thing, right? Monitor your network activity. That's not something that we would ever ask operations to do, and that's completely fine. We are going to talk a little bit about how we can leverage IT within a SCADA or control system type environment. And then train operators. I mean, what could some of the signs be that an operator can monitor and witness on a control system that could lead to a virus of some kind? And an example could be having the hourglass on your screen constantly where your cursor is. It could be your computer could become, your SCADA host could become, for example, completely unresponsive. And if that's the case, and if that's happening, then operators need to be trained that they suspect an issue, and they need to be told who they can call. When you start talking about cybersecurity and the remote access aspect of it, the first thing that needs to be addressed is people. Because people need to be organized and aligned in order for remote access to be implemented in a secure manner. And that's a hurdle. It requires a bunch of different people from a bunch of different divisions within your organization or municipality to be aligned. And that can be like herding cats. I'm speaking based off experience. So make sure you have buy-in from all of those parties that are necessary to give you as an operator the thumbs up to get remote access at the end of the day. That's what it's about. And the second item that needs to be addressed is the technology. Here we have things like a firewall. We spoke about that. We have things like a virtual private network, a VPN. You guys may have heard of that. In order to set up a secure remote access connection, a virtual private network should be deployed. And what is that? A virtual private network is basically a connection between 2 points on the internet that become dedicated and encrypted. So you'll see here this pipe between these two firewalls, and that pipe you should envision that as a pipe that nobody can penetrate, and that's dedicated between these two devices. So it's a secure connection. And then we have, as far as the technology is concerned, we've got managed switches, and we've got fancy things like LANs, local area network, and virtual local area network. I'm not sure if there's somebody in the room that is a little bit more IT savvy, but that's the intent of mentioning this. And then there's things that on your control system, if you have it deployed and accessible from the internet, you might want to consider something like intrusion detection type systems, so that you can actually have a software solution monitor your control system to see if there's anything unusual on the go. And if it does, it's critical that that then generates some sort of a notification or alarm that gets monitored by somebody who's knowledgeable on handling that. So when it comes to the design considerations, we always suggest to think about cybersecurity before you actually implement a remote access scheme. It's kind of like the horse and the cart. You want to make sure that you know what you're going to do, design something first, and then build it. Implement role-based authentication and authorization. That's that username and credential thing. Make sure that you have that managed. Make sure that you're secure and up to date. And then utilize experienced personnel. We support that. The world of control systems, remote access, is highly technical. And I would imagine that most of you guys have resources within your organization or municipality that you can access to help you out with those types of things. And then the last one is important too, is the fact that cybersecurity is not static. It's something that will always evolve. There's new threats coming out, as I showed you earlier, daily, and lots of them, which means that new patches are coming out, which means that they need to be deployed. The architecture may change. You guys might have new facilities that get expanded in your operation, that maybe get connected to your control system, to your architecture, things alike. So cybersecurity needs to evolve just like you guys do with your process. Show of hands. Wake up, everybody. The Internet of Things, IoT. Who's familiar with that? Excellent. We've heard of it. I love it. The definition of the Internet of Things. Now, again, this is something that is applicable when you have remote access. But the Internet of Things, the definition is it includes all devices that are connected to the Internet while sharing real-time data. That's critical. Share real-time data. So, what are some examples? Well, you've got a little Alexa sitting at home that will play your music. That's an IoT device. Your Tesla, yep, that's an IoT device. Your home security cameras, you can whip out your cell phone and see who's at your front door right now, right? That's an IoT device. Your Fitbit, absolutely. Your wallet tracker, for those who lose their wallet all the time, with a little locator in it. Hearing aids that you control off of your mobile device. Your smart light bulb, change the color in your room. All of those are IoT devices because they share real-time data through the internet or your Wi-Fi network at home. Now, why am I talking about this? Because we are now starting to use the Internet of Things philosophy in process control, and it's called the Industrial Internet of Things, IIoT. Yes, we added a letter to the three-letter acronym. But that's the idea. We are using it, and it's here. It's real. So next time when somebody asks you, who's familiar with the term IoT, I hope all of you guys will raise your hand. I'm going to talk a little bit about IoT, and the reason I am is because this is, I believe, where the future of process control is moving towards. So in this picture that I've put on this slide, I have put down a maybe traditional level monitoring type process with a pump. What we have is the blue is the process, and the black items on this little picture are process control. So we have a pump that feeds into a tank and a reservoir of some kind that has a little transmitter on the top of it that records the level. The level is wired, the transmitter is wired into a PLC, a controller, and that controller presents that data onto some sort of an interface. That could be a panel-mounted interface, or that could be a SCADA system, or that could be a mobile phone. It doesn't matter. But that's the traditional method of process control. The SCADA host or the HMI displays that. I put the last bullet on there, round robin polling. The reason I put that on there is because this is critical in how current, the more traditional process or SCADA systems or control systems are communicating to remote devices, and it's different in this IoT example. So what is round-robin polling? If you have a municipality where you have a couple of different reservoirs and a couple of different lift stations and maybe a well or two, you have these distributed throughout your municipality, and you have one centralized control system or one HMI or a SCADA host that sits where you monitor all of that, all of these remote sites. Then your SCADA host will, through a wireless or wired network, doesn't matter, reach out to that first site, and it'll say, hey, are you there? And then the controller at that site, could be a reservoir, responds and says, yeah, I'm here. And then the SCADA system says, okay, give me all your data that you have for your levels and for your pressures. And then that controller on that site responds and feeds all of that to the SCADA system. And then the SCADA system says, okay, I got it, thanks. And then the controller says, over and out, and that communication then is then closed. That was only the communication to that first site. Now you have 10 of those, so now your SCADA host reaches out to the second site, and that repeats over and over until you've communicated to all of your different sites. And that's not a big deal. You have 10 sites, and the communication to each and every one of these will take a second or two, and that's relatively quick, because before you know it, you're going to be polling your first site again, and if anything happened between the poll and the second time that SCADA host comes around, you'll see it updated on your SCADA screen within a few seconds. If you have 100 sites, you see where I'm going with this, it's going to take a little longer. And what if something critical happens at that site right after that regular poll of that particular site happened? You won't know about it until the whole SCADA system has gone through every one of these sites and starts all over again. That's different in this picture when we start talking about this IoT device. Now, this picture is, the architecture is a little bit different. What this picture talks about is how you can replace the traditional method of communication from your transmitter that is on top of your reservoir and that used to be wired into your PLC. In this particular case, in this instance, the transmitter is not wired to the PLC anymore. It is actually pushing data onto a cloud. Now we're talking about using the Internet of Things, just like any of these examples that we talked about, right? Like your doorbell. From the cloud, the data that is pushed onto the cloud, which is now your level, that data is now displayed onto your SCADA system. So it's no longer going through a PLC, it's going through the cloud, and from your SCADA system, it is fed to your controller, to your PLC. And then that PLC will start and stop your pump based on that level. So it's a different way of thinking. But the beauty of this is that you can expand your existing control system with one or two of these types of devices. And we've done that for these guys that are sitting in the front here, Regional District of Nanaimo, because they ended up having a communication infrastructure that started failing. And in order to simplify their architecture and not having to dig up lines, we ended up with the Regional District of Nanaimo putting this type of solution in, and it was relatively low cost, it was relatively easy to install, and it's worked quite nicely since. So this Internet of Things, which started out being, used from your smartphone to your banking, see who's at your front door, it's certainly and really quickly stretching into process control. Yes, you guys will know this picture because this is at one of your reservoirs where we were actually doing that install. We were installing one of those level monitoring devices, and it is now publishing data to the cloud, and the SCADA system is fetching it from the cloud, feeding it to the PLC, driving the pump that fills up the reservoir when it gets a little low. So no more round-robin polling. Every IoT device will push data to the cloud when it's told to do so, and immediately the SCADA system will get a notification that new data is posted on the cloud and pull that data from the cloud and update the process graphic So operations will see an update in that level, and that will then result in a change of that level in the PLC, which will then turn the pump on or off. And if you look closely on this picture, the lower left picture, you'll see somebody sitting there with a fuzzy vest and black hair and a ponytail. That's her. So what's the risk when you start talking about IoT integration? The risk is that your SCADA software may or may not support that. And that's because it is a new technology, it is a new protocol. Protocol is a language, if you will, between process control devices. So you do need, in order for this IoT to work on your control system, you do need a SCADA system that supports the protocol. Now there's third-party software that can help enable that protocol, so we can talk about that, but there might be some software limitations. I put the other one on there to say that the resistance from something new or to the cloud. And I've said this before when we started talking about remote access. Lining up people to all be in favor of something new being implemented to a change can be hard. And part of that is because of cybersecurity. Now, I can assure you that the protocol that IoT type devices in the industry is using is safe and secure. But in order to convince maybe your IT department or your IT consultant of that, might need a little bit of work. So what are the benefits? Well, I've hinted at the fact that this is a low-cost solution. You purchase some of these devices for $1,000, and all of a sudden you have level monitoring up and running again. So that's a pretty good deal if you have a remote site. Data retrieval is fast. No more traditional communication architecture. So if you have aging infrastructure, you can step away from that safely. And even if you have very poor cellular connection at that site, considering the amount of data that is coming off of, for example, monitoring a level, it's so small, it is such a tiny little bit of data that just a tiny little bit of cellular coverage on that site will provide you the data to come through. So I've started talking already a little bit about integration with IT, and when it comes to this current technology and how you can incorporate that into your control system, the world of IT is very different compared to the world of operational technology or your control system. Your control system is often called operational technology. IT talks about data. IT guys typically worry about networks. They worry about printers, they worry about desktop, they worry about access, but they worry about data. Restricting data or allowing data, it's all about data. Whereas in the operational technology, we worry about process control. We worry about equipment, we worry about being able to turn a pump on and off. So back in the day, the control systems were completely disconnected from IT. You had a city hall, or you had an office environment with networks and a printer and a computer, and you had process control, and they were not connected physically at all. Nowadays, and if you want some of these features that we're talking about today, you will need to connect these two worlds. And it's not always easy. There's a bit of an overlap. What we can certainly help you with the fact that the world of IT is very different. The world of OT speaks English, but it's often not the same language. The facilitation of the two worlds and the blending of that together, this overlap between the two pictures, that's where we live. Some of the differences between IT and OT are listed here, and the most important one is the priority. Your control system, priority number one, is availability. Your control system has to be available in order for you guys to operate your plants. From a IT perspective, confidentiality, access or restricting access is the top priority. So that's very different. And the rest of these items, such as maintenance, when can you do maintenance on a control system? Well, that needs to be scheduled. You need to make sure that your operations can run your maybe your plant in hand for some time while you take your control system down, things alike, right? Whereas in an IT world, and we've probably all seen an email that, some network server or the email server gets updated on Saturday between, 8 a.m. and noon. And really? It's okay, right? We don't really care about that. You can't do that with a control system. As far as the network is concerned, even though it's an Ethernet cable, we're talking about very different protocols, which is a language, such as Ethernet. Ethernet is basically a language. In your process control environment, the way that devices are communicating over an Ethernet cable is very different compared to an IT type environment. So a significant difference. Security. Very different as well, because once you're on a control systems network, you want all of these devices to communicate to one another. You want your VFDs to communicate to your controllers, to your PLCs. You want your remote sites, a reservoir to communicate to a pump station. You want a lift station to communicate to your wastewater treatment plant. All of that has to be open and ready to communicate. While in the information technology, it's all about access restriction. The life cycle of operational technology, when you talk about controllers, it's probably decades. Whereas in information technology, in your city hall, computers typically get replaced every so many years. Controllers don't. And the priority response is a significant difference as well, where if an issue comes up in the control system environment, it will need to be addressed immediately, just like your pickup truck if it doesn't start up in the morning. Whereas, depending on the nature of the issue within an IT environment, it may not have to be addressed right away. It can often wait. So those are some significant difference between the worlds of IT and OT. So if you guys are thinking about taking that next step of making a control system available remotely, of connecting that to the world of IT, these are definitely a few things that you might want to think about. But what's the value? Why would you? Well, some of these technology trends that we're covering today can add great value. Connecting those networks and working with IT can greatly improve the performance and take a whole lot of worries off of control system operations type guys. Because you can use IT resources to help you monitor, for example, your control system for strange activity, for potential threads, for somebody who shouldn't be on there, for maybe even somebody who's come into your plant and has plugged a laptop into your control system network. There are great solutions out there that are probably already in use in larger municipalities where that is normal within the world of IT, and we can certainly expand that in the world of OT. So implementing some of the technologies that we're talking about for things like remote access, we can use some of this IT infrastructure that is already well established in an IT environment and roll that out and make use of it when you start talking about that control system functionality. So remote access, authentication, there's great value in making sure that if you have a resource that works in your municipality and an email address is set up for that person, that user account is now shared immediately with your control system. So that if another person is no longer with your municipality, that access to email, but also access to your control system is immediately removed. And then virus protection, it's a normal thing in the world of information technology, IT, and it should be in the world of OT as well. And we can use IT technology and tools and experience to do that in your control system. Same with patching. So at the end of the day, why would we consider working with IT? It's to reduce cost, to increase productivity. Because what do we have in common? Well, they're both highly technical, and they require experience and expertise that is very, very focused and very dedicated. Even though the network hardware is often the same, like I said, you can have an Ethernet cable. The way that devices communicate over those Ethernet cables can be very different. We can still definitely use IT knowledge to expand the functionality of your control system. And as I often say, we always make fun of each other. We think IT guys are geeks, and IT guys think that SCADA guys are geeks. And of course, the last one is cybersecurity, and we've already talked about that. So if you are looking to take some steps and integrate with IT and think about some of these technical aspects, figure out what ultimately you want to, where you want to go. What do you want to get out of your control system in the long haul? And then start talking about that. Start thinking about where, from an operational technology and from an IT technology, there are, where it synchronizes, where there's overlaps, what we can benefit from one another, and figure out who is responsible for which component out of that full architecture. Now I'm starting to talk a lot more IT type stuff, but it is important for the larger municipalities where you have IT departments that may or may not completely understand operational technology and where operation technology ends and where IT technology begins. You know, this is a very technical picture that I'm not going to spend much time on, but if you go back to my SCADA 101 slide at the very beginning of this presentation, you know, we talked about the process level. Well, that's the bottom one, level 0, the green one. And from there, it works its way up. Level 3 in this picture is that supervisory control level, and that's all operational technology. And it's critical that if you start talking about integration with IT, that you figure out who is responsible and accountable and pays for these different levels of within your architecture. This is a very generic, high-level architecture picture. Like I said, I'm not going to spend too much more time on it, but we can certainly talk more if anybody is interested. Consider the role of your SCADA system during an emergency situation. You know, if you think about BC over the last couple of years, there's certainly been a bit of a, higher frequency of emergency situations of different kinds. And, you know, you think of fire, you think of floods, you think of, you know, obviously the earthquakes that may or may not come about. And if you start thinking about operating your water or wastewater systems, I encourage you guys to think about what role your SCADA system can play in that scenario. So we always think about, you know, the guys like fire, police, and paramedics that are immediately deployed when there is an emergency situation, but at the same time, utility operators are called out immediately after that, and we never seriously spend a lot of time talking about that, but we need to, we should. So if you as a utility operator ends up responding to an emergency situation of some kind, you need to start thinking about what if a component out of my control system is no longer operating as I expect it to today. You know, what's going to fail? What's probably going to fail first? Well, I can assure you, based on my experience, it's your communication infrastructure. And the pictures that I've put on here speak for themselves. If you have wireless communication, that's a higher risk. Towers getting knocked over by wind, earthquakes, trees falling on lines, etc. So what I'm saying is, maybe we should start thinking about how are we going to control our facilities if we have no communication infrastructure anymore. Well, this is a picture, again, is that very first picture from that SCADA or Control System 101 that I started out with the 4 different levels. And if you take that communication layer out of this picture, how are you going to control your plants? Yeah, you can possibly control them locally. You can possibly control them in manual, and that's okay. For an hour, for a shift, for a day, for a weekend, for a week, for a month. So we need to start thinking about how we can use our SCADA system to minimize that type of impact. And there's definitely ways that we can do that by adding redundancy. And you can take redundancy to the nth degree. You can make anything and everything redundant. Obviously, now we're talking about cost. But if you identify the items first that you think are the highest risk or most critical in your architecture of your control system, then maybe those are the ones that we need to be tackled first. So make a plan. I encourage you to think about that. I encourage you to take backups. I encourage you to, like this picture here, potentially, and we know some users that have a mobile communication tower sitting on a utility trailer in the backyard of the public office, of the public yard, and they can pull that to a site and power it up with a local generator, and it will act as a replacement communication tower in case something catastrophic were to happen with their centralized communication tower that is currently enabling communication from all the remote sites in a utility to the main SCADA system. So the reason I wanted to stress a little bit about on this is because some of these Public Safety Canada and NIST recommendations in that guideline, they really nicely line up with some of these emergency response plans that you can put in place. What I'm saying is that if you are planning an emergency response in your municipality, they very much already will line up with some of these guidelines for cybersecurity. So you can kill two birds with one stone. Switching subjects, alarm management. Yes, we're going to talk about, like I said, a variety of different type tools and how can you keep your control system current. Well, alarm management is one of those examples. What is alarm management? Alarm management is the philosophy that you can implement in your control system that believes that any alarm requires an operator to take action. Let that sink in for a moment. Any alarm requires operator attention. So if there ever is an alarm, and as an operator, you guys look at that and say, oh yeah, okay, that's fine. We'll acknowledge that and it'll go away. Then I believe that should not have been an alarm. That should have been an event, but it should not have triggered an alarm. Let me give you an example. If you have a tank, a vessel of some kind, and on the discharge side of that, you have a pump that has a low flow switch on the discharge of that pump. I believe that that low flow switch most likely will be an alarm currently in your situation if that pump is not running, because there's no flow, right? So then if you go to your alarm summary and you look at all the active alarms in your control system, that low flow switch will probably say it's an alarm. But then you look at it and you're going, well, the pump is not running. Of course, that low flow switch is an alarm. What I'm saying is that that low flow switch should be programmed in your controller, in your PLC, to only be active if the pump is running. That's alarm management, because that's how you minimize the number of alarms that an operator needs to process. Better yet, it's going to take a few seconds once that pump starts for that low flow switch to actually register flow, right? And therefore clear itself. So your process, your controller should actually be programmed to say that low flow switch should only be an alarm when the pump is running and the pump has been running for, let's say, 10 seconds. That's a very simple example of alarm management. And that's a technology, a way of thinking that is relatively new. And we can incorporate that in any control system right now. You don't need a 2022 version of the latest and greatest SCADA and control system in order to incorporate that. You can do that in any type of controller. And it minimizes the number of alarms that operators get on callouts or even to process in a regular day. So there's great value in that. So that's where I'm coming from when I say any alarm should require operator action. So when we talk about this type of stuff, we clearly already have mentioned the fact that different alarms should probably be categorized differently within your control system to be an event or to be a high priority alarm or a low priority alarm, and whether or not it should generate a call out. And it's our belief that when we build control systems, that we provide that functionality to operators. They operate locally. Why not allow these operators the control to trigger the alarms that they need to respond to? So alarm management, in a way, could or should, in an ideal world, be thought about when you design a facility, when you design a control narrative, and when you start programming a PLC. But it's never too late. This can certainly be done on an existing control system. Typically, like I said, have operators give them the ability to change alarm priorities so that they can change alarms whether they generate a call out or not, and revisit those strategies from time to time. It adds value. On your SCADA system, there are the more modern SCADA systems. They can aid in the alarm management philosophy on implementing it by providing some intelligence that in a lot of SCADA systems nowadays natively comes with the software, and it allows an operator to see, for example, which alarms have generated, or which events have generated the most alarms, which conditions. So if you have, just like in this picture on the top left, you'll see there's two that stand out. The bar graphs show that those are the alarms that have come into your control system the most in a certain period of time. And if you're taking on this initiative of alarm management, then you can take one of those, for example, per month and say, we're going to take that alarm, the one that has come in the most, and we're going to investigate why. Is it a faulty switch? Is it poor configuration? Is it alarmed right around that level when it usually operates or hovers? All of these things may be true, but by addressing, let's say, one per month, you can greatly reduce the number of alarms that operators will have to process. So great value in doing that. The rest of these graphics that I've put on this slide are just simply showing some statistics about the alarms that happen to come with this particular SCADA solution. And I've mentioned the alarm controls. I've mentioned the fact that we strongly believe that from an operational perspective, operators should have the ability to enable or disable alarms, to adjust the set points, to adjust the severity, and even the delay. What's the delay? Well, the delay is if a process condition has tripped a switch, how many seconds do you want to expire before you actually generate the alarm? And you want this in order to make sure that a level is not fluctuating right around the alarm set point. So if you built in a little bit of a delay, it will make sure that that condition has to be true for the number of seconds before that alarm actually is generated. And the last note is important on this slide, where it says actions taken on the HMI or SCADA should be reflected in the PLC or RTU. What does that mean? It means that any change that is made on on your interface related to your alarm control should be written to the PLC. The PLC is that controller on your site that is robust, that doesn't need to be rebooted. Your SCADA host sometimes does. And in order to make sure that all your interfaces that are connected to the PLC are showing the same values, it's important that any changes get written to the PLC. So some of these questions you might want to ask yourself. Can you acknowledge alarms individually? Is there an automatic reset? Some facilities have a reset that is required on some alarms, but not on all. Do we understand the difference? And the last bullet here, for example, do all alarms require operator action? And in my humble opinion, the answer to that should be yes. The future of SCADA. Where are we going with this SCADA stuff? Well, we've talked a lot about remote access, we've talked about IT, we've talked about this Internet of Things, we've talked about a little bit of cloud with this IoT stuff. There are SCADA systems out there that no longer require a computer in your plant, but everything will be on the cloud. And that's another concept where if you want to start talking about it, IT people might have a fit. At the same time, I don't know about you guys, but I personally use the cloud an awful lot. We have no problems with our Hotmail, with our Gmail, with our Google Drive, with our OneDrive. We have no problems with doing your banking online, right? So we need to start thinking about the fact that we no longer may need an actual SCADA server sitting in your water plant or your wastewater plant. The benefit of having it on the cloud is upfront cost. Sure, you have ongoing cost, like a subscription type model, but somebody else is going to do the patching. Somebody else is going to worry about the updates for you, and you don't have to replace your computer that's sitting in your water plant or your wastewater plant every so many years. You won't have hard drive failures anymore, so there's a lot to be said for that. And I truly believe that over time, we are going to get there for all of us. It's out there already. We really should start thinking about it and talking about it with management and with IT, because we're going to get there. Data management, I put data management up because data management is becoming a bigger and bigger thing. We all know that back in the day when a lot of us started in the industry, you would have a transmitter and it would generate 4 alarms. A low, low, a low, a high, and a high, high. Nowadays, you purchase a transmitter and it has an Ethernet port on it. And aside from these 4 alarms, this thing can probably generate 147 different alarms about self-diagnostics and all of that type stuff. And a lot of that is mapped into the SCADA host. A lot of data is being generated from every single one of these types of transmitters. There's more devices, there's more data points per device. We are flooded with data. And the amount of data that we collectively are getting in front of our nose is increasing very, very fast. We need to manage that. There's great tools out there that can help with that, not only from an operational perspective, but also from a managerial perspective and also from a regulatory perspective. You know, fishing out and picking out that tiny little bit of data out of this massive bucket of a historian that you might have somewhere in your organization. That's going to take a little bit of planning, a little bit of organizing, and sometimes tools, data management type solutions that generate the proper report or the proper dashboard or the proper alarms. So it's becoming a bigger and bigger thing is what I'm saying. So the future of SCADA really will have to include data management. Machine learning and artificial intelligence, and we've all heard these terms, right? Where over time your device itself is learning behavior and it's starting to anticipate what normal behavior is. And SCADA is already, process control, is already moving to that as well. If you have a reservoir where your low, your pump kicks in to fill it up is at 60%, and if it typically stops filling up at 90%, then there's many controllers and process control devices out there that will see that normal operation is between 60 and 90. And they will automatically, these types of devices, start generating alarms if your levels are exceeding those normal operating limits. So we may not have to generate hard-coded low, 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 high, and high, high type alarms anymore in the near future, because that's what's already happening. It can add great value. It certainly can. And it's in its earlier stages right now in process control, but we're going to get there. And then augmented reality, and you see the picture on the bottom right. The fellow who is walking through this particular facility is wearing the funky visors. And with those visors, it is connected through Wi-Fi to the SCADA system. And he's actually capable of looking through these visors at a piece of equipment in the facility, and if he then holds his fingers and does a certain motion, like tap twice, a virtual screen opens up, just like the projection of your speedometer in your fancy car nowadays, that allows an operator to then control that piece of equipment that he's looking at through these visors. He can start that piece of equipment by tapping on this virtual interface. It's augmented reality. It's here. Many SCADA systems these days support it. Obviously, it comes at a cost, but for a lot of us, I am suspecting that there will come a time that we're going to be walking around our facilities with these funky glasses on. The beauty of this is, of course, is that you no longer need a centralized SCADA system, right? You don't necessarily need that. You need to run back to the control room because it's all right there in front of you. I've spent a lot of time racing through some of these slides. I wanted to make sure before I started with this, yes, I always end with this, right, don't I? That this is a PowerPoint that touched on a whole variety of different current technologies that can be incorporated in your control system. And I apologize if this has gone very fast. The reason that I wanted to touch on them and I wanted to make sure is that you will have access to this slideshow after the event. So if any of these types of technologies that we've touched on really might be applicable to you guys, by all means, please reach out, give me a ring, shoot me an email, and happy to explore that in a lot more detail specific to your application. That was quick.
Test. The cloud application, is that different to VMware? Like, because a lot of IT people now they run VM servers. You no longer have a physical server with a SCADA or any other application. In our SCADA application, we actually have two, a main and a backup. Both are virtual. Not a physical machine anymore. Is that considered cloud, or is cloud bigger or different to that?
It's related. What I suspect you might have is a server somewhere in your environment that runs a virtual server, a virtual machine. Exactly. And you can run a number of instances of an operating system in a virtual environment. So you can have one server that really hosts via software, 5 different servers on one physical server. That's a virtual machine, a VM environment. What I was talking about when it comes to cloud SCADA is that you would have basically that, but it's hosted on an Amazon cloud or somebody like a TELUS type cloud, or maybe even your Google, but so that it's not on site. So that a third party looks after the virtual machine that is then operating truly in the cloud.
Check. How do you see this Internet of Things and cloud-based things reacting or interacting with current regulations and dependency on availability and for controls and things like that for regulated equipment? We've seen things like with, for example, another organization, technical safety and boiler controls. It's not there yet. We've got a long road to go. How do you see that happening or going with yourself?
Well, first and foremost, tomorrow at 1 o'clock, we're talking a little bit about cybersecurity and regulatory requirements and things like. So that's a panel discussion at 1 o'clock tomorrow. How do I see that happening? I think it's in its infancy right now, and I think that we don't have the structure yet that at some point we're probably going to need and will require. Yeah, we're very early on.
We've got Schneider Schneider control system. It runs our geothermal system and boilers and so on. I've got two parts to this question. The first one is, how hard is it to pull into that our wastewater and water systems into the same software package that we already have for our geothermal building, heating and cooling systems? So that's one question. The other question is, considering a cloud-based solution instead of a local hosted solution, what about a hybrid where we have both? You talked about the backup solution. I really like the idea of a cloud-based, but also we're a big and remote facility. We need the ability to see it, even if it's just on site and we lose our internet connection. So is there sort of a confluence of those two things, having both local and cloud-based?
The answer to your two questions is easy and yes. No, I'm serious. I mean, you're asking how hard would it be to integrate additional sites into an existing Schneider control system? And I imagine that you would have some sort of a SCADA software solution. It becomes a licensing issue. You purchase a SCADA software license based on the number of tags or devices that you communicate to. So if you are expanding that, and if you're centralizing your SCADA host solutions instead of having three separate ones, and you want to merge them into one, yeah, you can easily do that. Schneider software is very capable of doing that, but it becomes a licensing issue. That's about it. Your second question, the hybrid, the backup, redundant SCADA type solutions, it's very common to have two SCADA servers, one primary, one backup, and not have them in the same physical spot. So you can have one in your water plant, you can have one in your public yard, you can have one in your water plant and one at your district office, you can have one in your wastewater plant and one in the cloud. Absolutely. Not all software solutions manage this the same, not all can do this as easy as maybe the next, but here Bart goes again. Some are the GMs, some are the Dodges, some are the Fords of the world. Control systems are like pickup trucks, and they all excel in different areas that will be defined by your requirements. And that ultimately is why you pick one pickup truck, and that's ultimately why you'll pick a certain SCADA software solution. Can be done.
For the machine learning piece, are the usual suppliers of SCADA software starting doing machine learning application, or different type of software, MATLAB, for example?
SCADA software vendors are integrating machine learning type solutions. Absolutely. This is where things are moving. Yeah. Yeah, so you don't need an additional software solution, if that's what you're asking. 9 times out of 10, you may not need that, no. Obviously, it's a current technology, it's a new technology, so if you have, a 1990 vintage SCADA system, well, you're going to be challenged. Any other questions?
Do have we just have a virtual question that we're trying to interpret. So is it possible to have a manual as default? I think there might be a typo. An OT as hydro failure is a reality to us. That question makes sense to you. Can we make sense of it? Or maybe the person who put the question in can add a bit more. It could be default to IT and OT, as hydro failure is a reality to us.
Is it also obvious? Okay, is it possible to have manual as default to IT and OT as hydro failure is a reality to us? Right.
Oh, if the hydro goes out?
Yeah, absolutely.
Okay.
A default setting within a control system being manual versus auto, absolutely. That's simply user selection.
So meaning you can switch it back to manual automatically?
That can be done.
Okay.
Yeah.
What if he's asking for failure to manual as opposed to failure, as opposed to just a blackout?
You know, I've said this to a lot of our customers and clients. You know, from a programming perspective, we will program what's typically documented in what we call a control narrative. And a control narrative is basically a document that outlines how, written by engineers, this facility is to operate. And we have yet to be challenged that we cannot program what a narrative is asking for, because it's programming. Whether a default should be manual versus auto, a 1 versus 0, based on a series of conditions, absolutely we can do that.
I'm still stuck on the cloud thing because I like it, but my background with the SCADA system is very manual, kind of old school. I had a hard time wrapping my brain around not having physical servers in a room somewhere, even if they are offsite. So one of the concerns I had is just based on the diagram that was up there, is if you're making control changes on your SCADA system that's going in the cloud, you want those have to be written somewhere else. Because if you lose your cloud, or if your SCADA, which is a cloud-based thing, dies, your control cannot be compromised. It has to continue regardless in your actual plant, whatever that plant be.
Yes.
So is that happening in the cloud? Like I'm assuming that's considered already as
Clearly.
as somebody's understood that.
Yes.
I don't know if I'm making sense, but sorry.
I think I understand where you're getting at, and I sense that there's a hesitancy, a risk in not having local SCADA software and servers. Right. How often do you worry about losing your connection when you do your online stuff? And it depends on where you are.
Well, never, I love it when my cell phone's not on.
But my point is that if your Wi-Fi doesn't work, you transition to your cellular connection. So that's a backup. It's all about that. It's all about building in the redundancy that makes your discomfort disappear. And we can put triple redundancy in there when it comes to a dedicated internet connection versus through an internet service provider, with a cellular backup, with a satellite backup. All of that can be done. Absolutely.
And the local server.
Absolutely, of course, yes. And the hybrid, yeah, in this example, you're right, I focused on a cloud type SCADA solution, but you can definitely have a local SCADA solution plus your triple redundant cloud SCADA solution, absolutely. Yep.
What's a real life, so if someone got in through the back door and got past your firewalls, what do they do? That's what management asked me, so they could shut the water on and off.
That's a great question.
Yeah, so what would that person do if they got
Last year in Florida, there was an operator who was sitting in a water plant, and he was not actually physically looking at the SCADA screen, but he was working beside it, and he all of a sudden saw the mouse move. Nobody was touching the local mouse. And then the set point for chlorine injection changed from a setting to a factor of 1,000 times that setting. And he looked at that and he thought that was strange. So he moved his mouse, he grabbed the mouse and changed that set point back to what it should be. And immediately after that, it changed again to a factor of 1,000 higher. Then he alerted and rang the alarm bell, and it turned out that an unauthorized user had connected to that interface and was obviously malicious and was looking to clearly increase that chlorine injection to a point where it would absolutely become a public safety hazard. So what can individuals do maliciously? It very much depends on your control system. If you limit the set point entry to maybe 3 times the maximum of what normal set point entry should be, then the limit and the risk is not really even all that big. But if you allow that set point to be increased 1,000 times the normal set point, then that impact could be massive. But yes, remote control, starting, stopping equipment, you name it, anything that a guy can do, a person can do, even while walking into a facility. I mean, what can a guy do? Start, stop equipment, stop water, environmental damage, public health safety. Absolutely. There's many different cases out there. We can talk about this a little bit, that we can explore and give you some real examples of what hackers have done.
Yeah, no, I know what I could do, and sometimes management doesn't get the severity of what someone's going to get. If you do a water plant, what you can do around.
Absolutely. It's public health and safety.
Question. Do the benefits of a cloud-based control system outweigh the risks of the effects of a malicious security breach that could have?
I think that's a great question, but I think that very much depends on the comfort of the users and how many levels of redundancy are implemented to provide that level of comfort. So I'm dodging the question in a way, right?
Okay, one more question from online. What do you do if everything is in the cloud and comms go down?
Before that happens, implement a redundant communication infrastructure so that comms, when they do go down, automatically fail over to your backup communication infrastructure. It's a very common question. Yep.
I think there was another question in the audience here.
In the beginning, you mentioned the statistics that water and wastewater utilities are particularly vulnerable. So that's the fact, that's the statistics showing the number of attacks increasing. My question is, why is that? Is it that they are more vulnerable or that they are somehow a better target? What's the backstory there? Because that trend may increase in the near future.
That's a great question. I'll be honest, I don't have the answer. But I wouldn't be surprised if it's a combination of exactly what you mentioned. Yeah.
I'm wondering how much of that is that we're not doing enough to protect ourselves as compared to the power generating industry or the air traffic control system, which probably invests billions into security. Maybe utility management isn't doing enough. But I don't know that. Is there a way to answer that?
I don't have the answer. That would require a little bit of research and a little bit of digging, but certainly.
Like to comment on that last question, and our scenario was that the original installer, not only did he use admin as the password, the username and password for logging in, but also he put the whole system on port 80 so that we could access it easily, and he wasn't an IT guy. So I think the thing there is that the OT installers are often not IT minded and locking it down behind some obscure port number or something like that.
Very valid.
Just follow up for this gentleman's. Is it something to do with the regulation, I guess? That's why, that statistic shows very high risk on wastewater and water. That's compared to the electricity part where we have Western Energy Council and FERC.
Could very well be.
Something to do with, revamping regulation in terms of cybersecurity and stuff.
Yeah, could very well be, right? Very much so. And again, we're going to be speaking about this tomorrow at 1 o'clock and have a panel discussion about the cybersecurity and the municipal water, wastewater industry. Yeah, it could very well be.
What do you think about passwords for PLC?
The problem with that is I don't necessarily disagree with passwords for a PLC, as long as the code itself is still available for maintenance and support. That's what I think the question is about access to the PLC, and I'm good with that, because access to a SCADA system or the credentials to a network are always, username and password combination, and to roll that out to a SCADA host is universally accepted. To implement that at the PLC level, I'm okay with as well. What I'm not necessarily supporting is to block access to logic that executes your plant control, so that somebody new who is supporting your plant is not able to access that code. I hope that answers that question, realizing it's not necessarily yours. Well, unless the programmer doesn't want the next guy to have access to that code. I'm not necessarily a fan of that.